Good morning, everyone. My name is Doug. Thank you for being here. I'm going to take you back to 1982. For me, it was my spring semester, my freshman year in college. I was doing Fortran with punch cards, and I realized most of you aren't going to know what punch cards are, what Fortran is, or what 1982 is. Some of you are old enough there to handle that one, but bear with me. So actually, I'll go back a couple more years. Even in 1979, I purchased my first computer. It was an Apple II computer. I loved it. I did anything that I could. I did as many contract work programming gigs that I could possibly get. So back in 82, I was working for a local computer store. Again, just trying to network and get as many jobs as I could get doing some programming development work. And a blind individual walked in the door, and he talked with the owner for a while, and eventually I got called over. Turns out I got recommended to do a little programming gig for him, and I thought, well, of course, this blind individual can't use a computer. He's going to need help. How can a blind person use a computer? Well, it turned out this blind person actually created a self-voicing talking word processor for the Apple II that allowed blind people to actually create documents, edit the documents, print out the documents, and be able to have with some confidence that they've got something that they could hand to a sighted user. So what he hired me for was to create a copy protection scheme for this on those 5.25-inch floppy disks, that because he wanted to start selling this. He created a company called Computer Aids Corporation, and the individual's name was Bill Grimm, both pioneers in the industry. And I ended up working for him starting then until he actually closed the business in '89. So that was kind of the beginning of my blindness industry. But what was interesting to me is that at that time, it was common for blind users to have to use dedicated self-voicing applications to get their job done. So if you wanted to go work with somebody and you have a sighted person next to you, they're using whatever every other sighted user was using at the time, but this blind individual had to use dedicated self-voicing applications to do their job. Now, if you had some custom applications for the environment that you're in, good luck with that. You probably can't get that job. But if they're just doing word processing or something where there were some self-voicing applications, that blind user had a pretty good chance of getting in there. But again, it was kind of in their own little world. They had their own applications. Imagine that today, if that were today. Luckily, that changed. Somewhere around the mid-'80s, we had the concept of screen readers came out. That's sort of when DOS was first released, Microsoft DOS, and the computers started coming out. And now all of a sudden we had this thing called a screen reader that actually came out on the market. So what is a screen reader? A screen reader is just an assistive technology device that, just like any of the other devices that someone with a disability might use, it's just an application that they launch. Now, back in the day, they also had to have dedicated hardware plugged into a parallel port or a serial port back in the day. But it's the eyes for the user. So what you take for advantage, or what you just take, obviously is up on the screen. The screen reader is going to be the eyes for that user. It typically conveys the information through speech or through Braille. Imagine if I'm deaf and I'm blind. Maybe Braille is my only option. So a screen reader is going to convey that information through speech and/or Braille. Presents information that's visually obvious. You might look at something and say, well, I don't know necessarily it's called a tree view, but I know how to interact with that with the mouse. The user has to be told specifically what these items are that they're going to. I'm on a checkbox. It's checked. They have to know how to interact with that control from the keyboard. Again, a sighted user just takes it for granted, takes the mouse, and they click on it. So the screen reader is going to give them that extra information that they need. It also allows them to read information on demand. So maybe, typically reading focus is obvious as I'm focusing around my application. But it's also, at times, maybe they walked away, got a cup of coffee, came back, where am I? So they can hit commands that will maybe read the title bar of the focused active window, or the focused control, or the line I'm on, or many other commands that the screen reader user is going to know how to deal with to be able to get oriented again of where they are. And typically, screen readers are very customizable. No one blind screen reader uses the screen reader the same way as another person. They've got different needs. Maybe I want to hear keys as I'm typing. Maybe I want to hear words as I'm typing. Maybe I don't want to hear anything as I'm typing. Maybe I want to hear OK button or button OK. The screen reader gives them that flexibility, assuming the application is accessible. It gives them that ability to be able to customize it to their specific needs to make them as productive as possible. So I'm going to give you a quick, brief history of screen readers. I mentioned they started around the mid-'80s when DOS came out, and they were called screen readers because that's pretty much what they did. They would go to the screen and they would read the information back to the user, or they would intercept. Remember TSRs back in DOS days, terminate and stay resident programs? They would just sit in the background and hook in the APIs as application developers would write text to the screen. The command prompt was a good example. It would read that as it flowed to the screen. But if you're using WordPerfect back in the day, and you hit the up arrow to the next line, well, that didn't get rendered through those APIs. So how did it read it? Well, the screen reader would see a key was pressed. It was the up arrow. It would say, OK, video card, where's your cursor? OK, video card, give me the text of that line. It was very easy. It was 80 by 25 grid. Of course, at the time, I thought it was very complicated. But in today's terms, it was very simplified. So it's very easy to go to the video card and get that. Then what happened? Windows was released. It kind of turned everything upside down. No longer could we go to the video card and get that text. And so what screen reader developers typically did was they kind of did what they were used to in DOS, is they would create their own off-screen model. They would actually still hook all the text outs and the pat blitz and the bit blitz, all that information going to the screen. They would hook all that in userland, keep track of all of that, keep in their own little database off to the side. So instead of going to the video card to get where the line is, they would actually go to their little off-screen model and get that text and be able to read that. So that's how they got along for a while. But it was clear that's not sustainable. That's not a good solution. So Microsoft kind of stepped in, worked with the assistive technology vendors at the time, and said, how can we do this better? We need an API that's going to allow us to go from your application into assistive technology. And so they went through several iterations. I won't bore you with all those details, but they ended today with UI automation, or UIA, which is the standard today. And the platform, the Windows platform, has gone to great detail to make sure that you get UIA for as free as you possibly can. And the frameworks have also been updated, whether you're using Win32 or WPF or UWP, whatever you're using, those applications are going to use as much as they can for free for you to expose that information to the screen reader user. So a lot of times, application developers don't even think of accessibility, don't even believe that a blind person could possibly use a computer, let alone think about it, and they're getting this stuff for free. But there are cases where you still have to go in and maybe polish a few things to make something maybe accessible or maybe usable. Just because something's accessible doesn't necessarily mean that it's usable or productive for a screen reader user. So that's a real quick overview of screen readers in general and how they've evolved. Windows has built within it a nice screen reader that you can use for your testing purposes, and blind users can use as well for free. It's called Narrator. The shortcut to start that is just Control Windows Enter. That's a toggle. So if Narrator's not running, it will start it. If it is running, it will stop it. So that's a great way to just launch it real quick and test your application. Just some real quick things you might want to know about Narrator. There is a developer mode in there for developers such as yourself. If you're not understanding what the speech is saying or you didn't quite get what it said, you can press Caps Lock Shift F12 and it will actually display on the screen the information that's being spoken. So sometimes, again, it just kind of helps you figure out what it's saying. That's a toggle as well that you can turn on and off. And just some miscellaneous commands. There's a lot of commands, but the one way to find out what the commands are is Caps F1. That will bring up a list of all the Narrator commands, just to give you an idea of what a screen reader user has to go through. But if you're just looking for a specific command, that's a great way to list all the Narrator commands. Some of the ones that really stick out to me are a screen reader user, again, they go get a cup of coffee, come back, they may want to know where they are. They could press, for example, Caps T to read the title bar of the active window. They could press Caps W to read the entire window contents. So whatever the active window is, it would just start at the top and just read it to the user. But also, because we're using this programmatic access now with UIA, we also give you the ability to traverse this UIA tree. So all these UIA elements are represented in a tree structure, and I can use Caps Lock left and right to go to the previous element in that tree or the next element. So that allows the user on demand to be able to navigate up and down through my window to be able to read the information, even if it's not, let's say, in a tab stop, where it's just some random static text that's up there. They could read the whole window, that's kind of tedious, or they could just navigate to that text and read it on demand. So just some quick keystrokes that you might be interested once you launch Narrator. So what are some issues that a screen reader user might have when they're using any application? They have to understand terms and concepts sighted users don't. So they have to understand tree view, checkbox, radio button. Again, a sighted user doesn't necessarily know those terms. They need to know that because they don't have the visual representation. Now they know how to interact with it based on the term. And they're going to know how to do it from the keyboard, assuming you guys gave them access from the keyboard. They also interact differently than documentation, sighted users, or help desk. Suppose I'm working in an environment and I call the help desk because I'm having a problem. They might say things like, see that little graphic up in the top right? Go ahead and click it. Well, they have to deal with issues like that and educate people that, okay, you got to give me something a little bit more to go on here to be able to get to what I need to do. Same way with documentation may be written, assuming a sighted user. The mouse, of course, is typically useless. The physical mouse is typically useless by a blind user. So you've got to make sure that the application is exposed fully through the keyboard. Unlabeled images. If they come to an image that might visually represent something very obvious, it may not be so obvious if it's not been labeled. Now, some of this new technology that we're doing with screen readers, we talked about the API, which is a cool step, but we also have using AI now. And so through cognitive services, Narrator has the ability to take an unlabeled graphic, send it off to the cloud, let it analyze it, come back and give a verbal description of what that image is. So that's really some cool stuff, just at the cutting edge of being able to take advantage of AI for assistive technology. And custom controls can often be difficult for individuals using a screen reader. Now, just because it's a custom control doesn't mean that it's not going to work, but it has a higher chance of probably not working. So we typically suggest that developers such as yourselves use standard controls so that the user is going to be comfortable and know how to interact with that. Typically, everything is linearized for a screen reader user. Think of everything going through a funnel. So regardless of how complex your screen may lay out, to a screen reader user, it's all linear. They're just tabbing through, they're arrowing through everything in a linear fashion. So sometimes that's easy, sometimes that's more difficult depending on the application. Also frustrating is false or missing information. If I tab to a checkbox and it doesn't tell me the state, that's useless. Or if it tells me the wrong state, that's probably even more useless. So we need to make sure that and that's getting better with the programmatic access and such, but that still happens to screen reader users. Also just being efficient. They're being bogged down with all these things that I just listed. We need to make sure that the applications are as efficient as possible. And I'm going to go through some examples of how you might do that to make your applications a little bit more efficient. And I would argue, if it's done properly, there are cases, easily cases, where a screen reader user can more effectively get through or get where they want to be quicker than even a sighted user could do. So some design principles for developers such as yourselves of how can you make your applications work with screen readers or any assistive technology for that matter. Again, standard controls, if at all possible. The platform has good support. The framework has great support. If you utilize standard controls, you're going to get a lot for free. Programmatic access, if you are going to use standard custom controls, you may have to implement your own UIA implementation for that control or polish some of the other areas that maybe you've deviated a little bit from a standard control. You may have to get in there and just tweak things a little bit with UIA. And I'm going to show you how you can do these things. And again, make sure your application is fully keyboard accessible. Don't touch the mouse. Run your application strictly from the keyboard. Can you do every feature in your application? And then finally, just test it with a screen reader of some sort. Windows is very easy. It's got Narrator built in. Control Windows, Enter, tab around, and see how it's going to work. There's also other screen readers on the market that you can also use to test your application with. But if you leave here with anything today, I want to make sure you leave with the aka.ms/dev4accessibility webpage. That's a great resource. It has everything that you need to know in far more detail than what I'm saying now of how to make your applications accessible, how to test to make sure that they're accessible, everything from the ground up. So enough of me talking. Now what I'd like to do is switch over and I'm going to go ahead and launch Narrator. I'm just sitting at the desktop. I'm going to go ahead and launch Narrator with Control Windows, Enter. Hopefully we've got some voice. I'm not hearing the voice. I need some help on getting my voice.
Tooltip.
There we got it. Thank you. So Narrator is just going to voice this information to the user. So I'm just going to go quickly to IE, which I have that specific web page up that I was talking about. A screen reader user can just navigate through this page top to bottom if they choose. They could just down arrow and go through every element of this web page. They could tab to the individual links.
Azure, link. Office 365, link.
So I could just continue to tab, continue to arrow as I go through this web page. But also if the page is done correctly using maybe some ARIA markup or just standard HTML, you can also navigate it quicker by, let's say, going by headings. Standard HTML, visually, there's a lot of headings on this web page. Visually, it draws your eyes to these sections. Why not allow the screen reader user to quickly get to these sections as well? So all screen readers are going to have a command that allows you to jump to a heading.
Heading level 1, developing apps for accessibility.
So I just hit H, and with narrator, and it took me to the first heading that was below where I was at. If I hit H again,
Heading level 2, get started.
notice that's a heading level 2, so it kind of gives me some hierarchy of what's going on this page. If I keep hitting it,
Level 3, developing apps for accessibility. Heading level 3, accessibility overview.
so maybe I get to where I want to be. Now I could just down arrow and be able to read that content.
An overview of the concepts and technologies related to accessibility scenarios for Universal Windows Platform.
And on and on. I can also jump between maybe landmarks, which are larger groupings within a web page. So I can either use regions or landmarks to block off large chunks, maybe search a search landmark or a header landmark or main content landmark, allowing the screen reader user to quickly get to where they want to be able to be. Just to quickly show you how the screen reader works inside, let's say, Word with some
0%
complex text. As I arrow through the text, it's going to read that information to me.
Paste in the embed code for the video you want to add.
I can just go by word.
You can.
I can go by letter.
And November.
I can also just do caps R, which is a narrator command.
You can also type a keyword to search online for the video that best fits your document. To make your document look perfect.
I'll save you. That will just read the entire document down. A lot of sighted people like to do that. I do it for proofing documents. A lot of times just sit back, put my feet up, listen to the document read to me, and I'll catch errors that I just visually wipe right over. Also, let's say the ribbon, which is kind of a complex control. Even visually, it's a little complex. If I hit the Alt key to go up there,
Ribbon tabs. Selected. Home tab item. 2 of 11 Alt. H.
told me I'm on the Home tab. It told me I'm on 2 of 11, so I know how many are up there. If I continue to tab,
Clipboard. Paste. Collapse. Split button. Alt. H. Pick a paste option. Such as
so that gave me a lot of information. It told me I was in the clipboard group. It told me I'm on the paste button, the type of control it is, the shortcut for it. Lots of information came through. Again, I continue to tab.
button. Disabled. Alt. H.
Just keeps reading off that information. Now, there's a lot of controls up on that ribbon. I don't want to have to tab 50 times to get to what I want. So actually, Word gave me the ability with control left and right arrow to go to the first element of each of those groups, clipboard, font, paragraph. So if I do control right,
Font. Colibri.
I go to the first item under font, control right again,
Paragraph. Bullets. Collapse.
and then I can tab within that group. So that goes from being accessible to usable just by adding that little keystroke that's up there. Just real quickly,
Settings window.
under the settings window, we just recently, in the latest release of Windows, added headings and landmarks within UI, not just on a web page or within standard applications. So I can, for example, here just
Scan. Ease of access. Heading level 1. Vision. Heading level 2. Hearing. Heading level 2.
I'm just moving by headings. Again, I could tab around this, but there's a lot of tab stops, a lot of arrowing. This quickly gets to me where I want to be. I could also go by landmark.
Group. Main landmark.
That puts me over to the right on the main landmark, and then I could just start tabbing
Everything bigger.
and go through every item that I want to be able to go through. So just adding little headings and landmarks to this framework, which is already accessible, makes it more usable to the user. So what I'd like to do now is just quickly show you a little XAML application.
Accessibility sample. Microsoft Visual Studio Win output. Pane. Deploy started.
Oops.
Ready. Ready. Ready.
I'm going to silence it there, but it's basically a brain-dead application that I just quickly threw up with some XAML, and just to kind of throw you or show you some concepts that you may have to deal with in an app. So I'm going to test this by tabbing through with Narrator.
Description. Editing. Submit. Button.
So that was kind of odd. I expected tab to take me down to the contact email, not to submit. So if I hit tab again,
Contact email. Editing.
a sighted person isn't going to notice this. They're going to take the mouse and click on these individual controls and click on submit. A keyboard user, that's very annoying that the tab order was wrong. I'm
First
going to,
name. Editing.
so far,
Last name. Editing.
going good.
Send it. Button. Previous. Button. Button.
That just said button. It didn't say next. So again, that's a problem. So I've got really two problems here that I want to address. One is the tabbing order, and the other is it didn't speak the next button. But let's just see if I can navigate it around by headings, because visually it looks like this is Doug's sample app might be a heading. It looks like feedback might be a heading. Miscellaneous might be a heading. And it'd be great if there was a landmark around a navigational landmark around previous and next. So if I try to do that, let's just see.
Scan. No next heading. No previous heading. No next landmark. No previous landmark.
There are no landmarks or headings on this document at all. So let's fix that as well while we're going in there.
Tooltip. Stop debugging.
So we're going to go ahead and stop this. Just so it doesn't over-talk me, I'm going to go ahead and shut down Narrator. And I'm going to fix these problems that are up there. So the first problem we had was the tab order. XAML does a great job of giving me default tab order. It just goes top to bottom. So how you lay out your XAML markup is how it's going to be in the tab order and also in that UIA tree. So you want to keep that in mind as you're designing this. The tree structure just going top to bottom. So it's going to start with tab order at the top, which is fine. And it's going to keep coming down. There was title, there was description. Notice button is in between those two. That's why button was in the tab order before my content, my email contact. So what I can do is I'm going to take my contact and just copy it out, cut it out rather, use the right keyboard, cut it out, come up here and paste it in. And so basically I just put it above my button. Now visually it's not going to change at all because I explicitly put positioning on my controls. So that's not going to adjust my visual at all, but make the tab order now be correct. So hopefully that's right. Now we're going to go fix the other problem of the next button not speaking. The previous spoke because right here, XAML was smart enough to take the word previous and put that in my UIA tree for me. It gave me the UIA name of previous. But when I come down to my next button, notice I used a graphic image instead. And so because of that, I actually have to go in here and manually put in my UIA name for this. So I'm going to go ahead and do automation property name. Now, my previous talk on Monday, I showed how you can do this automatically. It'll point out these errors for you automatically. But I just kind of wanted to show another way that you can do that. So I specifically went in and said my UIA name is next. Localization may be an issue here. You got to make sure that that gets localized as you're doing that. So now this is going to work. But before I run it again, I'm going to go ahead and just put in some headers in here as well. So my main heading, which was this is Doug's sample app, I'm going to do, again, just a UIA automation property. And I'm going to give it a heading level. And I'm going to give it a heading level of 1. And maybe down on my submit feedback, which was another visual looking heading, I'm going to do the same thing. And I'm going to give that a heading level of 2. And see, then we can maybe come down to the miscellaneous section, which was also a visual heading. Oops. Automation properties, heading level, and we'll give that also a heading level 2. And while I'm at it, I'm going to put in one landmark here real quick. This is a stack panel that has the next and previous buttons. I'm going to go right in that stack panel and put in an automation property of a landmark. I could give it a custom name, or I could use one of the standard landmark names, which I will. And I'm going to call it a navigation landmark. So now I fixed all of these problems very quickly. I'm going to go ahead and run it again. Hopefully it'll come up quickly here. And so we fixed the tabbing order, we fixed the next button, and we now have headings and landmarks within our document. So as soon as this guy comes up, there we go. I'm going to go ahead and launch Narrator real quickly. Almost done.
Starting Narrator accessibility.
So first of all, does the tab order work?
Contact email, submit,
it does.
button.
I didn't sacrifice my visual UI at all. Let's go down.
Next, button.
Next is now saying button. Let's try going into, let's try doing some headings in here.
Miscellaneous things.
I went previous heading.
Submit feedback. Heading level 2. This is Doug's sample app. Heading level 1.
Let's say I want to get to my navigation real quickly.
Route. Navigation landmark.
There's my navigation landmark. I can tab to whatever I want and hit enter, and I'm done. So very quickly, it allowed me to make that application fully accessible and actually usable as we did that. So in conclusion, I just want to put your call to action to continue your education at the 2 web pages that I've got up here, the aka.ms/dev for accessibility and microsoft.com/design/inclusive. Great utilities to help you figure out what to do with your apps. Test your application with Narrator or any third party or any other screen reader on the market. And considering hiring or consulting with a screen reader expert or user so you can get some good feedback of how your application should work with a screen reader. If you have any questions, our booth is actually in accessibility, which is under client and web. I can see it from right here. Feel free to stop by and we'll answer any questions you may have. Thank you very much.